In this video, let's discuss about the term expectation in probability analytics. The dictionary meaning of expectation is a kind of projection. Let's study expectation with examples, then establish a definition to it. Vamsi and Taran play a game. Vamsi gives Taran a toffee when the coin they throw throws a tail. Taran gives Vamsi a toffee when the coin they throw throws a head. Now, what is it that you expect after say n number of rounds of this game? I mean, how many toffees would Vamsi have gained or lost? The question is, what is it that you expect given there is equal probability of throwing a tail or head any time? The question is, what is it your expectation about the number of toffees Vamsi would lose or gain? Here we need to discuss about the three things. Firstly, possibilities which are to win or lose. Second is the yield or outcomes of the possibilities which are 1 toffee plus or 1 toffee minus. The other one is the probability of the occurrences of the possibilities. First, let's discuss the possibilities. For Vamsi, a head will win him a toffee, so let's take this possibility as a +1. A tail would be a lose for him. So, take it as -1. Now, we could establish x-axis or say domain. Now, since there is equal probability of tail and head, there is equal probability of win and lose. So, a win plus a lose plus a win plus a lose, so on yield or outcomes a 0. The other way of telling this is by finding the area of the function. When we draw y-axis appropriately and evaluate the areas, we have two areas, a negative area and a positive area. The net sum is 0. Thus, we expect that VAMZ is neither set to lose or gain. Corresponding generalization for continuous distribution is as in equation format is also shown. And since finding the area is nothing but the integration, we have the expectation defined as expectation equals integration of multiplication of the variable x, probability function on f of x multiplied by infinitesimally small interval dx. And, this is how we define the expectation. Note, there are only two possibilities, win or lose, no other intermediate possibility. Hence, this isn't continuous function. So, histogram is the better way to represent this discrete problem. A continuous function representation like the graph in the bottom is not appropriate. Function representation like the graph in the bottom is not appropriate.